Hi, everybody. We're going to go over some of the homework stuff here, and we're just going to talk and forget all about the fact that I hit record on that. How many people get a little nervous? Nobody with recording? Good. So we went through chapter 1, introduction, and on that part right there, we saw the video, and then I made notes of those videos, and we talked about the different variables, right? So here are those notes. We talked about variables, and variables are things that vary. So there's, if we look at humans, hair varies, eye color varies, height varies. There are these things that vary between humans, and if we were to measure that in a statistical way and, try to do some studies on it, gain some insights into something that varies between people or between whatever it is we're looking at, the things that we're looking at would be the things that vary between the things we're studying. There's a whole lot of vagueness in there, but variables are things that vary. And then we looked at different types of variables. We learned about qualitative and quantitative. Qualitative is also categorical. Quantitative is numeric. We have discrete and continuous. Discrete are whole numbers, right? Integers. And continuous are fractions or decimals. So you guys are just going through all this. And if we were to measure the number of water balls in this class, that is discrete or continuous? Discrete, right? It's going to be a whole number. There'll be like 7 water balls. But if we measured people's height, is that going to be discrete or continuous? It's going to be continuous. Somebody will be like 5 feet 11 and fractional amounts of an inch. Time is going to be discrete or continuous? Generally continuous. We could say, hey, we're measuring it in seconds, which could be considered discrete, right? So depending upon what we choose as statisticians to measure, it could be discrete or continuous, but generally time would be measured in fractions of a second, right? Like how fast was it? And then we have more words like to talk about different ways that we talk about numbers and how we measure stuff. We have nominal, ordinal, interval, and ratio. We went through all those. And then we also have univariate, bivariate, multivariate, so all of that. And then we have the sample and the population, right? So everybody feel pretty good about those things. And if you're in the online class, there are other lecture videos which are linked, and those other lecture videos are from my previous class where you can learn more about that. But I just want to make sure that we have a new book here, and with this new book, I want to make this lecture here so you understand how to use Canvas and everything like that. But right here, video lectures from a previous semester, you could learn more about those variables and the things we just talked about in that. So the next deal is we're going to look at this one. So let's launch that. So we're going to click that, and then we're going to click into this, and we're going to learn some good things about SALT. There's a little tool that we could use, and it's called SALT, and it stands for something, but I don't remember what it stands for, nor do we have to remember what it stands for. Okay, but when you come in here, you have more stuff to do, and so you have different things to read about and things to answer. Give a brief definition of the term descriptive statistics, right? And give a brief definition of the term inferential statistics. And so you could use ChatGPT, you could use any AI to, please explain to me what's descriptive statistics, please explain to me what's inferential statistics. You could take a picture of this, a screenshot of this. You could go to ChatGPT, or you could go to Grok, or you could go to Gemini, or you could go to Copilot. And at any of these places, you could say, please tell me how to take a screenshot on a Mac or whatever. And it'll tell you how to do a screenshot on a Mac or on Windows or on whatever device you're on. And so you could take a screenshot of this. So on a Mac, I could do Command-Shift-4, gives me this crosshair, and I could highlight both of those right there. That gives me an image. I could go to my Finder, and in my Finder, I could go to my desktop, and that image is right there. I could come back over here to, ChatGPT. And on some of these, to upload images, you have to pay. You could just try ChatGPT. You could try Grok. You could try Gemini. You could try Copilot. And, you could see if there's one that allows you to upload images for free, but you might have to pay $20 a month or something to use it. Let me know what you discover. So next week, let's talk about this and let me know what you're using. And anybody using a free one that lets you upload images, let me know now. What are you using? ChatGPT, but after like 3 images on the free version, it says you have to pay. No, you get 3, that's it. Is there one that gives you unlimited free uploads? Google's Gemini does? Okay, do Google's Gemini, so maybe you do Google's Gemini. Huh? Questions AI, I haven't heard of that one. Okay, well, try Gemini. I have heard of that. You can say, please answer and explain the questions in that image, and then it'll explain it to you. We talked about this on Tuesday, but I just want to make sure that you're all aware of that. And then you can answer it. You could also just like click a button, hit submit, and it'll give you the wrong answer. Or maybe you'll get lucky and get the right answer, and you could read it and you can understand it. And if you got the wrong answer, you could try something else and submit it. I don't know how many times you could do that. So try it and then let me know, like after 10 times I wasn't able to submit anymore. I'm sure there's some setting. I just haven't gotten to it because it's a new textbook that we're using in this class. Questions? Yeah.
Do you know if the search engine allows you to just type in inferences and look it up?
Yeah, you could go old school and you could say, please, tell me, describe inferential statistics at the search engine, for sure, and the search engine will give you a definition of inferential statistics. Inferential statistics defined. And it's in the textbook. And you could also, this is really good, thanks for pointing that out, you could also say, read it. And if you click read it, thank you for asking that question. It launches the textbook right to this place, right? And then you could be like, okay, and you could read this, and you could read the textbook, and population and a sample, so there's a definition of population and sample, and descriptive statistics and inferential statistics, all right? And so you could read the textbook right there and come back and answer it. So that's super handy. That might be the best way to go. How many people that's been useful, just seeing this stuff here? Say aye. Okay, good. All right, so that's all of these, and those are pretty good. And these 1.1, 1.3, they correspond to like the different sections in chapter 1 in the textbook. So if you get a physical copy of the textbook, I like having a physical copy of the textbook and just reading the book. That's really useful, but I know that's more expensive. So, and then here we have 1.4, and so 1.4 actually has some stuff that we start to do. And, like in terms of like, oh, let's look at numbers. And some of what we're going to do in here is we're going to look at dot plots and we're going to look at histograms. And so those are probably new words for you, but it's just a way for us to understand the data we've collected and start to get a sense of it. And so let me just show you what a dot plot and a histogram looks like. So here is a histogram, and here we're using some sort of categorical data. And this is the one that was the right answer, so I'll zoom in on that, right? But here we asked people, hey, we're a company, and we want to know which emoji makes the most sense for our customers when you like something that we did. Which emoji should we have? And we asked this is the hypothetical situation, we asked our customers that, and we have, out of 100% of customers, a certain percentage said they liked the star, some said they liked thumbs up, right? But this is a histogram, or actually this isn't a histogram, this is a bar chart. And in spreadsheets, they call these column charts. And a histogram, you'd have no spaces between the columns. How do you know this already? You're like, did you take statistics before? You just know this stuff. Oh, cool. All right, so if you ever have anything to add or chime in, or if I'm ever saying anything incorrectly, let me know, because I'm trained in business, not in statistics and decision sciences. So chime in if you feel like I'm not saying something correctly, because I don't have all the answers, and some of you know stuff I don't know. But here we have, this is a bar chart in statistics. In other classes, you'd call it a column chart. I think it makes more sense to call it a column chart because they're up and down like columns. Anyhow, this gives you an idea of how people responded, right? Out of 100% of people, about 50% liked the thumbs up. And so that's one thing to look at. And so in this example, you're looking at this data up here, right? You're saying, okay, and relative frequency is a frequency distribution is what's the frequency with which people responded to the different categories. So we have categorical data here, all right? And categorical is which word that starts with Q? Quantitative or qualitative? Qualitative, right? So this is qualitative categorical data, and we put people into categories. And if we were just out on the street asking people, like maybe we're asking people as they walk by on campus, we just put a little tick or a hash mark or something, and then we'd have like so many people here. Like let's say we asked 100 people, we would have 49 people here, and we'd have 12 people here, and 10 people here, and 4 people here, and 3 people here, and 22 people here out of 100, right? That's how many people there were. So that would be the frequency distribution, right? Like what's the distribution of frequency? How frequently did people choose this one or that one, right? Out of 100 people, it'd be this many people. And then relative frequency is like relative to all the people, 100, how many of them chose thumbs up? Well, what's 49 over 100? It's 0.49, right? What's 12 over 100? It's 0.12. So that's relative frequency. So you understand frequency. How frequently did something happen? How frequently did people choose this one? How frequently did people choose this one? How many people out of everyone we asked? And then relative frequency is this amount out of the total, okay? So does it make sense? And then you look at that data, and then you have to say, okay, well, based on that data, which of these bar charts describes that data? And this is descriptive statistics, okay? We're not making inferences. It's not like we studied a sample to make inferences about a population, right? But here we're just like describing the data that we've collected and trying to convey what we collected. And so it's descriptive statistics. So here we're kind of saying, okay, based upon this relative frequency distribution, right, which bar chart is the correct one to describe that? And we know that 49% of people like thumbs up. So I just looked at thumbs up here, thumbs up, and I looked for a thumbs up that's like at 49%. This is the only one. I'm like, that's it. And it gave me the right answer. Okay? So that's how you can do that. And then there's this thing, use salt. So if you click on use salt, it launches you into this kind of place where a lot of calculations get done for you. So here's my data. And this is really handy because you want to learn how to use statistics more than like how to sit there. I mean, we're also going to learn how to sit there with your pencil and actually calculate stuff. But it's nice when you could also just quickly see the calculations and start to make an understanding about what those calculations mean to describe the underlying characteristics of a sample. And so here's the data. And then we could go over here to descriptive statistics, and it's not available. And then charts and graphs, it says, okay, here we have the bar chart. Here we have a histogram. And we can come over here and select our data. So I'm going to select the response. And then here is my bar chart, right? So I can see that here, what that bar chart looks like. And it created the bar chart for me. I could see if it'll do that. It doesn't work for that. I could look at a dot plot, a scatter plot, bar chart, right? So you could just come over here and play with these. And we'll see this again in a second. But that's what salt is. So salt is really useful. So these orange buttons are useful as you're doing that, right? And also these buttons. So here, you can see you have a read it and you also have a watch it. So you could click watch it and you could watch somebody do this problem. And it'll show you how to do it. People. So great, right? Yes. Super great. And so it's time consuming. I've spent 5 hours probably on this chapter, and I'm the teacher because I'm reading the textbook, right? That took an hour or two. And then this morning I woke up at 4:30. I started working on this at 4:45, and I stopped probably about 6:30. So that's like 2 more hours. So now I'm more like 1 to 2 hours reading, 2 hours doing this homework. So about 4 hours maybe. But you got to put in the time with statistics. And there's a lot of stuff where I was like, really? There's more? It's taking forever, right? Like here there were 12, right? But you could read about it. You could watch a video about some of them. You have this area where you could start to play with the different little tools and see how it graphs out, right? So this is a bar chart. And then we came in here because we were looking for a histogram. I don't know if there's histograms. Not seeing it. A lot of bar charts, so let's go with bar charts. And then they have dot plots, and so you saw a couple of dot plots flying by, but I'm going to go with like the first one here. And so a dot plot is where you just take your data. So here's my data, right? And there's like, this is like concussion rate for, what is this? High school sports, okay? And so this is the correct dot plot right here. So if I took each of these data points, like baseball is 2.2, I'm going to put a dot there for baseball. And then the next dot, like softball is 4, so maybe that's softball right there. And then basketball boys, 4 is also right here. And so that's another dot. So that dot plot starts to kind of show you, because when you look at this data here, you're like, I don't know. What's that mean? I don't know. I don't know, right? Like, but if you look at it here, at this one, you're like, okay, I don't think I want my kids doing that sport, football, right? The most concussion rate. And I'm probably going to keep them out of these two sports. And this seems, or maybe. And these are the best, right? But you could start to see like, wow, this is a real outlier. It's a data that lies out away from most of the other data. All right, so that's a real outlier. So that's how a dot plot is used. And then you could go, all right, let me use SALT. And you could come into SALT, and your data's been transferred into here. And so here's this data, right? It's in here. And I could go over to the descriptive statistics, and oh, cool, I've got different descriptive statistics. And I could turn some of these off. We haven't learned about standard deviation. We haven't learned about that, so I'm going to turn that off. And we haven't learned about Q1, medium, and Q3, so I'm going to turn those off. But the mean is the average. So on average, and in statistics we call that the mean, there's like 11.7 concussions. Okay, that's the average. That's the mean. And the minimum value is 2.2 and the maximum value is 35.9. So here we're starting to describe the numbers that we've gotten from a study, descriptive statistics. And starting to allow us to understand the world. And when we understand something, the more we understand something, the more effectively we can operate with that thing or within that thing. The more we understand the world, the more effectively we can operate within the world. The more effectively we can make decisions. It's not an absolute view of what reality is definitively, but it gets us closer to the truth, right? We get closer to the truth of where our kids are going to be safe when we understand this dot plot here, depending upon the sport that they choose. And so that data can be really useful. Like, you know, should your kid play football? Well, let me look at the concussion rates for different sports. You know, I don't think it's a good idea. And concussions are,
Well, it's way up there alone, too.
Yeah, concussions are associated with, you know, TBI, traumatic brain injury, and so then you could also come over here and you could select a variable. You could just click these and play around with it. Like I'm going to choose concussion rate per 1,000 athletes. And then I could see, oh, there's a histogram. Okay, so that's what the histogram looks like. You notice there's no space between these. So, all right, that's all you need to know about a histogram at this point. It's like a bar chart, but there's no space between the columns. And then you could also do a dot plot. All right, there's my dot plot. So it did it for you, right? You didn't have to sit there and dot it out. But also, you know, there's a video in here on one of these right here. Watch it. You could see somebody do it manually. And you have to choose, right? Like statistics is something that is really useful to know. Most adults don't understand it. They get confused by it. But you have to invest in knowing it. And if you invest in knowing it, if you do what most people don't do, you're going to realize what most people don't realize, right? If you want to be the 1%, you want to achieve what most people don't achieve, you have to do what most people don't do. And most people don't understand statistics. And if you understand statistics, you'll be in that small percentage of people. And the more you do that in your life, the more you're going to achieve what most people don't achieve. The more you're going to rise above most people. So if you invest in learning statistics, and I'm talking about 5 to 10 to 15 hours a week, it's literally a challenging course. It's notoriously challenging. It's so challenging. Harvard taught statistics for 100 years before a kid at Harvard said, I'm going to take everything I'm learning and apply it to baseball. And he revolutionized baseball. And he completely transformed the game of baseball. And they made a movie about it called Moneyball. And a book was written about it. And Brad Pitt starred in the movie. And we'll maybe watch that movie at the end of the semester, Moneyball. But statistics was taught at Harvard for 100 years. The best university on the planet, that's the reputation, with the best students. For 100 years, they taught statistics. And only after 100 years did one of the students say, dude, what happens if I apply this to baseball? In a very systematic, and he revolutionized the game of baseball. And do you know when that happened? It was like 1997 or something. Not that long ago. So statistics is notoriously hard, and people struggle and suffer through it, and they get through it, and they're like, I'm done with it, and they don't use it. But if you are that small percentage that learns how to use it, it could help move you into that small percentage that realizes what most people don't realize, financially and all other ways. It's a really powerful tool. But you got to invest to learn it. It takes time. You got to read the chapter. You got to work through all this stuff, 5, 10, 15, 20 hours a week, right? And then you'll be like, okay, cool. And if you do great, I could hire you through the school, through the tutoring center to be a tutor in here. And then you could come back and reinforce your skills and make money helping other people learn it. And that'll help further reinforce it. So you could watch this video, and then there's something here, master it, where you could do more problems, but those aren't part of your grade. So here's another one where you could use SALT, and I'm just looking to see, and another one where you could use SALT, and there's one down here about prison populations. This is it. I didn't get this one right. You know?
Something wonky with that one.
Did you get that one wrong too?
I did.
This was kind of a fun one, and when you use SALT here, you have to go into SALT, and then you need to enter the incarceration rate per 1,000 people, right? And I forget, because it was so early in the morning, I think I used ChatGPT to calculate that. Now it's coming back to me. I just took a picture of this, and I asked ChatGPT to calculate the percentage of incarceration rate per 1,000 people. And I took a picture of this, and then I took a picture of this, and I said, please calculate that for me. But sometimes they won't give you the right answer, so it didn't give you the right answer for 7 either.
There
Jenny?
was some of them that didn't, but that's why I was thinking maybe I wasn't punching the stuff into my calculator correctly, but that's where I left off.
Okay. But that's okay. Like, if there's one wrong, don't sweat it. Just like, I'm moving on. Okay? So for whatever reason, maybe I got it wrong, or you'll see when you get there, but just move on. And then there was another one down here where it was like, which one was it? It was like this one here. I was just like, I don't want to have to do a dot plot on that. And there's no SALT, right? So I could watch somebody do a dot plot here, so I could launch this and maybe just go to the end of the video, and I could see what their solution is, and then I could like choose this. But you know what I did at like 5:50 a.m. this morning, or this is maybe closer to 6:20. I just said, okay, based upon this, like this is West Coast this is like seatbelt use rate out of 100%, okay? Or I don't know, 100 people, I don't know what it is. Yeah, it's a percentage, so out of 100%. And I just figured on the West Coast here, people are gonna be more likely to use seatbelts because that's the way the West Coast rolls. And in the Midwest, I think people will be less likely. And so I just was like, which one has a lot of people on the West Coast? And I tried this one first, and it was wrong. And then I just tried this one and submitted it, and it was right. And I'm like, okay, cool, that's the one. So you could do that, right? Like I got it. And then based upon understanding which is the dot plot for this data, I'm like, okay, it's this question, right? And if you don't get it right, click the other one. Sometimes they'll be stupid. You could just be like, that doesn't make sense to me. But if you understand what a dot plot is, and like how it could be useful, like we saw with concussion rates, and if you understand what a bar chart is, and you know how that could be useful, like we saw with, do you like which emoji, you know, on our website, then that's all really useful. And then that's it for these for the first module. And if you come across any that are really bad, I'm going to try to do all of the assignments with you every semester, but I've got a full life. And so I'm going to try to do it. But if you, like, I would drop, I forget which one I drop. I think I would drop, I don't know, maybe this one here with incarceration rates, but I thought that was really interesting. But there's one I just kept getting the wrong answers on. I'm like, what? Come on. But if you could let me know in class, just like, maybe we should drop that one, and maybe I could delete them out. But I thought these were all good enough. So that's it for the homework. Anybody have any questions? What's up, Jenny?
Would you please go over number 6 on that module?
Number 6?
Really aggravating.
That might be the one where I was like, maybe I should drop that one.
Is it?
Movie sales and use SALT. Yeah, this one was a pain in the butt. All these things here. There are the answers. Take a picture of it. No, there are the answers for that one. You could take a picture of it. It was hard. But, if you go into SALT, you'll start to get the statistics on it. And you can look up like the min, the max. And I'll show you how to do that once people stop taking pictures. And if you're at home, you could pause this video and take a picture with your phone, right? But those are the answers for that one. That one was frustrating. And you could also, I got this one wrong several times until I got the right answer. Some of these like words you had to fill in, I was like, okay, whatever. I forget which one it was. But what this is starting to teach us is looking at min and max to help understand our data. And then here, if we go in and use SALT, you could go to your descriptive statistics. And in your descriptive statistics, you could get rid of standard deviation and these, right? And you could see your min, your max, your mean. And the mean is the average. And so 2019 movie sales, 2020 movie sales. Why did movie sales in 2019 go from 298, what is that, billion? Down to 70 COVID, right? COVID in 2020 ruined movie sales. All right, so that's a little bit about those. Cool. Anybody have anything else? Great.